Hello guys, my name is Raju Vangola and I'm gonna give you a very brief introduction to what machine learning is. So basically machine learning is a subfield of artificial intelligence which has been evolved to teach the computers how to automatically learn a solution to a problem. Yeah, behind this many algorithms work, so that we'll be discussing in some of the few slides. But for the engineers, like this is mostly referred to as pattern recognition because the computer is extracting patterns out of the data that we have, and then based on the data we make a decision based on the pattern that is identified through working out on those algorithms. It is a rich field that is broadly and inherently related to signal processing, as mostly it is through the data driven learning methodology. Next we see is what is a classifier. A classifier is a system that inputs a vector of discrete or continuous features and outputs a single value through a class. So, for example, all of us have been, uh, all of us know what spam mails are. So, how the algorithm works for a spam mail? For spam mails, a spam filter is classified and it is it it separates the mail based on some of the few keywords in the mail, like it has to be separated as spam or not spam. So here its input may be any set of values, and then it is compared to a particular word that is in the mail, and if we find that word in the mail, then that is a spam mail, otherwise it is not a spam mail. And like this way the email system works for spam and not spam mail. So machine learning is what is a combination of everything that is around us for now. Like everywhere there is machine learning. If you take data mining, control theory, psychological methods, database information, everywhere the machine learning algorithms are applied because it is an emerging field nowadays. So machine learning is primarily concerned with the accuracy and effectiveness of what the computer system is. Next, we'll see the applications of machine learning. So where this machine learning is used, it is used everywhere as discussed. It is used in the web search for the search engine algorithms, the credit card fraud, speech recognition, even the image processing where like face detection, robotics, information extraction, even the social networking sites, everywhere machine learning is used. So next is we'll discuss about the algorithm components. So there are like hundreds and hundreds of machine learning algorithms because like every day there are new publications and every publication is coming up with a different algorithm each day. So like there are like hundreds and hundreds of machine learning algorithms, but behind this all the algorithms there are three major components which are very essential for machine learning, and that components must be there for a machine learning algorithm, otherwise the algorithm would rather be not optimal or may not even work. So, what are the three components? The three components for machine learning algorithms are representation, evaluation, and optimization. Representation is what a classifier must be represented in some formal language so that the computer can handle or understand that. Similarly, choosing a representation for a learner to understand the set of classifier is also important. So this particular set where we we choose the classifier so that the learner can learn. This is known as the hypothesis space. And if a classifier is not a hypothesis, is not in the hypothesis space, then that cannot be learned. So what kind of representation we can do? So like the decision trees are a representation of machine learning, a set of rules, a logical program, a graphical models which are further more categorized as in machine learning like Bayes, Markov nets, the neural networks which is further classified into supervised and unsupervised learning. All these all these are the representations which the machine learning uses. The next step is the evaluation. For evaluation, an evaluation function is used so that we can distinguish the good and the bad specifiers. Sometimes this evaluation function is also known as objective function or scoring function. Uh, Different people use different terminologies. The evaluation function is used internally by the algorithm can differ from the ones that are used externally to optimize the classifier so that we get an optimized result after which the evaluation is. Some of the methods that are used for evaluations are discussed in the next slide, like accuracy, the squared error, probability, calculating the entropy, the KL divergence. All these all these methods are used for evaluation purpose. Next is optimization. So what is optimization? So this is the last and final step in the machine learning algorithm. So we need a method to search among the classifiers in the language for the highest which classifier has scored the highest scoring function. So for that we need to get the optimized results, and the choice of the optimization technique is the key to the efficiency of the learner. The more the optimized is the algorithm, the more efficiently the learner will be able to learn them. It also Optimization also determines the classifier, also determines if the evaluation function has more than one optimum solution or not. So like there may be many optimized solution for an algorithm. So we need to get the most efficient among them so that we can get an efficient algorithm for the problem that we are looking for. The main idea here for optimization is that we should use the strength of one method to optimize the solution for the weaker ones. So it is not like that this algorithm is better and other algorithm is weak, so we won't be using that. Every algorithm is good amongst for a different set of problems. So we need to complement each other, and so that more algorithms and more efficient solutions can be get. So these are the optimization techniques like constraint optimization, combinatorial optimization, and convex optimization. So the example for example for the constraint optimization is the linear programming that we do. The combinational is the greedy search. We like we use the greedy algorithm to search for a particular optimal solution, and the gradient descent for the complex optimization problem. So this is a small introduction to machine learning course by me. Thank you guys for listening to me. Thank you so much.